Welcome to a lesson on scientific notation. The goals of this video are to convert between decimal notation and scientific notation, and also to multiply and divide numbers in scientific notation. Scientific notation, also known as exponential notation, provides a useful way of writing very large or very small numbers. For example, the U.S. national debt is now over $12,900,000,000,000, which could be written in scientific notation as 1.9 times 10 to the 13th power. The time it takes light to travel 1 meter in decimal notation is equal to this, which can be rewritten in scientific notation as 3 times 10 to the negative 9th power. Scientific notation for a number is in the form of a times 10 to the power of m, where a is a number in decimal form that is at least 1 but less than 10, and m, the power on 10, must be an integer. So if you take a look at this power of 10, if m is positive, you can see we'll be multiplying by numbers that are larger than 1. Therefore, when m is positive, when we convert to decimal notation, the number will be larger than the value of a. If we're multiplying by a negative power of 10, we would multiply a by some fraction, and if we multiply a by a number that's less than 1, the result will be a number that is less than a. Now that's important because when we convert from scientific notation to decimal notation, we want to understand why we're moving the decimal point either left or right. So if m is positive, the decimal point will move to the right m places in decimal notation, making the number larger than a. If m is negative, the decimal point will move left the absolute value of m places because the decimal notation will be less than a. So if we look at this first example, if we're multiplying by a positive power of 10, in decimal notation this number will be larger than a, and in fact to find that number we have to move the decimal point right 10 places. Let's go ahead and give it a try. We start with the value of a, and we have to move right 10 places. After moving the decimal 3 places, we end up here, and we have to move it 7 more places to the right. Therefore, we are going to have to add 7 zeros to this number. So there's 3, 4, 5, 6, 7, 8, 9, 10. Now to make it clear what our number is, we should rewrite this. So 1.245 times 10 to the 10th power is equal to 12,450,000,000. Now in the second example, we can see we're multiplying negative 8.75 times 10 to the power of negative 8. Multiplying by a negative power of 10 will make the number in decimal form less than negative 8.75. So now we have to move the decimal place. So now we have to move the decimal point left 8 places. Let's go ahead and give it a try. Now this negative sign is kind of in the way, so I'm going to eliminate it temporarily. Now we'll start moving left 8 places. As soon as we move it once, there's no more digits, so we have to add again another 7 zeros. So there's 1, 2, 3, 4, 5, 6, 7, 8 places to the left. So our number in decimal notation, remember, it is a negative value. So we have negative 875 10/1000ths. Next, we'll convert a number in decimal notation to scientific notation. And the steps are: move the decimal to form a such that a is at least 1 but less than 10. The number of places the decimal moves will indicate the value of m. If you move to the left, m is positive. If you move to the right, m is negative. Again, we don't want to memorize this, we want to make sense of it. So the first step is determine where the decimal should be so that a is at least 1 but less than 10, and that would be here. So far we know that in scientific notation this will be 7.6 times some power of 10. The question is, how many places did we move it to get it here? Well, it started here, so if we count over to where we want it to be, we'd have 1, 2, 3, 4, 5, 6, 7 places. It would be a positive 7. Since this is a rather large number, it makes sense that this exponent would have to be positive. On our second example, we know to form a number that is at least 1 but less than 10, the decimal would have to be here. So the value of our a would be 3.76. Again, this is a very small number, which indicates this will be a negative exponent. But let's count the number of places we had to move it to the right. 1, 2, 3, 4, 5, 6. Therefore, our exponent is -6. Okay, now let's talk about how you can multiply and divide numbers in scientific notation. If these two numbers are in scientific notation, everything here is being multiplied together. So it's pretty straightforward. We simply multiply a times b, and then multiply 10 to the m times 10 to the n. And to divide numbers in scientific notation, we divide a by b and divide 10 to the m power by 10 to the n power. Now, one word of caution: a times b and a divided by b must be at least 1 but less than 10 to be in the correct scientific notation form. So we may have to do a minor adjustment if a times b or a divided by b does not fit this requirement. Okay, so let's go ahead and multiply these together. So the first step is to set it up. This would be 7.1 times 1.3 times 10 to the third times 10 to the fourth. So we're really not doing much other than changing the order of multiplication. To save some time, I've already performed this multiplication. 9.23 times 10 to the power of 3 plus 4 would give us 10 to the 7th. Now a is at least 1 but less than 10, so we leave our answer in this form. On this next example, we set it up the same way, but when we find this product, we get 72.15 times 10 to the power of positive 3. This is the correct value, but not in the correct form. Remember, a has to be less than 10, so we need to convert this to scientific notation. This would be the same as 7.215 times 10 to the first times 10 to the third. So now the value of a is at least 1 but less than 10. So now we just have to multiply 10 to the first times 10 to the third to get our final answer, which would be times 10 to the fourth. To check this on the graphing calculator, we can open a set of parentheses, type in 9.25. If we press second comma, this capital E stands for scientific notation. Then we type in the exponent on the 10, and the same for the second, 7.8, second comma, and then -3. Close the parentheses, hit enter. Now the answer is in decimal form, but we can see that if we convert this to scientific notation, it would match our answer. Let's go ahead and try a couple division problems. So we break this into two parts. The first part will be 8.4 divided by 6 times 10 to the 12th divided by 10 to the 4th. 8.4 divided by 6 equals 1.4. 10 to the 12th divided by 10 to the 4th, we subtract our exponents. 10 to the 8th. Everything is in the correct form and we're done. To save some time on this last problem, I'm just going to go ahead and think of this as two division problems. 1.2 divided by 6.87 is approximately 0.179 times 10 to the -12 divided by 10 to the -3. -12 minus -3 would be 10 to the -9. Again, this is not in the correct form for scientific notation, but we can rewrite this as 1.79 times 10 to the power of -1, since we moved it to the right one place, and then of course times 10 to the -9th. So our final answer will be approximately 1.79 times 10 to the power of -10. Let's go ahead and check this on the graphing calculator. 1.23 second comma -12 divided by 6.87 second comma -3. And you can see our approximation is correct. I hope this lesson was helpful. Thank you for watching.